Hello everyone, this is another Physics 30 Alberta Diploma released question review. This time we're looking at multiple choice question 1 and 2. So here we have a child catching a ball. The question tells us that he exerts a force F on the moving ball for a time interval of delta t. Mass of the ball is given and its velocity changes from a plus 5 meters per second to a plus 1 meters per second as a result of this force. So here's our ball. It's flying towards the boy. As the boy makes contact with the ball, we're told there is a force. Now, this boy has to exert a force to slow this ball down. So hopefully you can see that the force exerted by the boy, I'm going to call this the force applied, is going to go this way. This force to the left is going to slow the ball down because the ball currently has a plus, it's got a velocity that is plus 5 meters per second. So I'm assuming that this side of the screen is positive and this side of the screen is negative. So here's my plus 5 going to the right, which means my force applied is going to be a negative. I just need to keep track of that. This 5 is the VI, the speed, the initial speed or the initial velocity of the ball, and then we're told that the final velocity of the ball comes down to 1. So there's a change. Incidentally, we should also think about what's going on with this ball. The boy is applying a force to the left side of the screen, this negative force, but Newton's third law also tells us that this ball is going to exert a force on the boy's hands, and this is going to be equal and opposite. So we're going to have this equal force applied to the boy. But we're not really going to need to think about that. The boy, we're assuming, is just standing still. We could keep going on and say that the boy is standing on the earth, and therefore the earth experiences a force, etc., but that's going a bit too far. So let's get into the analysis of this question. We're asked to find a solution, and it's going to be a calculation here. We also know that we've got some other values here. I'm just going to write them down. We've got the mass of the ball, we're told is 0.25 kilograms, and we're told that the time interval is just delta t. So, what do we know about momentum and impulse? Well, hopefully you can recall that if there's ever a change in momentum, which would come about as a result of an unbalanced force, which this ball is experiencing, it's experiencing an unbalanced force because we have this change in velocity, then we can talk about that force and multiply it by the time. That's going to give us our change in momentum. And we can also talk about this as a change in mv. We know that momentum is mv, so we can talk about this as an m delta v. And that's where I think we're going to head with this question, because we have two different velocities. In other words, we have a changing velocity and we have a mass. Okay, so if we multiply our mass by the change in velocity, we're going to get the change in momentum, which is the impulse, and that's what we're looking for. So let's keep going with this. This change in momentum, this impulse, I'll write that in, this impulse is mass multiplied by a change in velocity. Well, to get the change, we're just going to take the final velocity and minus the initial. So hopefully you can see we're pretty much there. I'm just going to put the numbers in. 0.25 kilograms multiplied by positive 5 meters per second minus our minus our 1 meter per second. Okay, and that is going to give us a delta P of, if we plug that into our calculator, 1 Newton per second. Or if you want to use the other units, you can quite easily say kilograms meters per second. Both are totally okay to use as units. And that comes up to, if we come up to our answer, there it is. The answer must be A. So we can tick that off and say that we know the answer. It must be A. For question 2, we carry on with this scenario, and all I really need here is my delta P, my impulse equation, because I'm interested in the force and the time. It's asking me if when catching the ball the child had applied triple the force, then the length of time that it would have taken to slow the ball would have been. And there's my various different answers. Well, in this scenario, there's no change in this value here. The change in momentum has to be the same. So what we're doing here is we're playing with this idea of adding force and therefore having a changing time. So to keep this value the same, to keep the change in momentum the same, which if we really wanted to, we could put that in because we just calculated it. So to keep this at 1 Newton second, I can do one of two things. I can change my force or change my time. And the question is telling us if we triple the force, what's going to happen to the time? Okay, so if this force goes up by a factor of something, then the time has to go down by the same factor. And so hopefully you can see that if that's the case, then my force is going to have to go up by 3, which means my time is going to have to go down by a factor of 3. So if I multiply my force by 3, let's go ahead and put that in. Let's get rid of those. If this is a factor of 3, then this has to be divided by 3 because our change in momentum has to stay the same. And that means that if we look at our possible answers, is it 9 times the original time? Well, no, because that's going to give us a bigger change in momentum. So it cannot be A. Is it 3 times the change in time? Well, no, because that's also going to give us a bigger momentum, which we can't have. A third, hopefully you can see that. If you're timesing your force by 3, you have to divide your time by 3. So there it is. It's going to be C. Okay, and we can put that in. We've got it. It's C. Happy days. There's our answer.